Okay, so now for the day 2 guided practice. Again, we're doing the Pythagorean theorem. So a squared plus b squared equals c squared. Now, let's see here. They want us to solve for x. So remember on these, I said the first step on the Pythagorean theorem, figure out where your c is. In this case, our c is the x. Okay, so let's set it up. 9 squared plus 40 squared equals x squared. 9 squared is 81. 40 squared is 1600 equals x squared. It's going to be 1681 equals x squared. If I had to guess, I would say 41. So let's see, because I have the 1 at the end. 4 times 4 is 16. So if I had to guess and do a wild guess, I'd say 41. But let's see. Square root of 1681. Yep, it's 41. So square root both sides, and you get 41 equals x. So that means x is 41. This is a Pythagorean triple. They're all whole numbers, 9, 40, and 41. Those are all whole numbers. So this is a Pythagorean triple. I'm even going to add that here. Just because I want you to get used to identifying Pythagorean triples. We have another Pythagorean triple. Now, it doesn't say that we need to be identifying these, but we're doing it. 9, 40, and 41. Anytime you get 3 whole numbers where a squared plus b squared equals c squared, that's a Pythagorean triple. Number 2, solve for x and round to the nearest tenth. My guess would be this is not going to be a Pythagorean triple, because I'll have to round to the nearest tenth. So first step, identify your c. The c is across from the right angle. So we're going to have 6 squared plus 5 squared equals x squared. Six squared is 36, plus 5 squared is 25. Add those together and you get 61 equals x squared. Square root both sides, and let's see, the square root of 61 is 7.8. So x is 7.8. This is not a Pythagorean triple. Okay, number 3, solve for x. So like I said, first step is to identify your c. There's our c. So now we can say 11 squared plus x squared equals 61 squared. 11 squared is 121 plus x squared equals thinking 3721 maybe. Let's see. Thinking it's 3721. It is. 3721. Subtract the 121 over. We get x squared equals 3600. Square root it, and we get x equals 60. Here's another Pythagorean triple. You're like, what's another Pythagorean triple, Mr. Schultz? These three sides, they're all whole numbers. 11, 60, and 61. That's another Pythagorean triple. Okay, number 4. Find the variables, round to the nearest tenth. This is one of those X and Y problems. Remember what I said. We want to find the right triangle that has two sides already found. Let's say I'm going to just go with the big one. Well, on the big one, I have a 5, an X, and a Y. I got X and Y on that one. I can't do that yet because I don't know one of those. I need at least 2. So that means I have no choice but to go with our small triangle because I know a 2, a Y, and the 7. So 2 and 7 are good. So it looks like I'm solving for Y. So let's see here. Identify my C. 7 is my C. It's going to be 2 squared plus Y squared equals 7 squared. 2 squared is 4 plus just Y squared equals 49. Subtract the 4 over. It's going to give me Y squared equals 45. Square root it. And I get Y equals, yeah, I'm not that good. Square root 45. 6.7. Okay, good enough. 6.7. So Y is 6.7. Now, what I'm about to do may kind of cause a head tilt. Like, huh? Why are you doing that? You'll see in a second. You'll see in a second. So, for Y, instead of saying, oh, Y is 6.7. Okay, I'm going to solve the other triangle now. I'm going to say Y is the square root of 45. But why? That looks nasty. It looks nasty now, but it will be nice at the end. It'll make our equation nice. And I like nice equations. I like nice equations and I cannot lie. These pencils can't deny. Okay, so identify the C. Well, my C is this 40 square root of 45. So 5 squared plus x squared equals the square root of 45 squared. 5 squared is 25 plus x squared equals square root of 45 squared just gets me right back to 45. See how nice that equation is now? There's no decimals. If I were to square 6.7, I would get a decimal and I'd still be dealing with decimals, but not anymore. Subtract the 25. And we get x squared equals 20. Square root that. And you'll get x, when you round, x is 4.5. There's x, there's y. Okay, number 5. They want us to find the variables, x and y. This one's a wee bit tricky. You're like, but why? Well, look at your two right triangles. I'm going to start with this one that's on the left over here, because I know two of the sides. So let me just get y before I get into the tricky part. Just going to get y. So let's see. Boom. Get my c. My c is 13. So 5 squared plus y squared equals 13 squared. 5 squared is 25. Plus y squared equals 169. Subtract the 25. Get y squared equals 144. Square root it, and you get y is 12. And you're probably thinking, okay, this isn't bad yet. You said this is going to get kind of tricky. Where's the trick? Well, y is 12. Now, for our other triangle, it's not this other small triangle, because I know that side is 13. That's not what they want me to find. I want to find x, which means I'm going to have to use this triangle that I just outlined in pink. Okay, so why do they even tell me that we've got two congruent sides here? Well, that's because this one right here is 5. So this whole side from the right angle to the tip is 5 plus x, or x plus 5. Now this is where it's getting a little, you may be kind of squirming a bit, like, okay, x plus 5, how am I going to do that? Well, let's start with the Pythagorean theorem. Find your c. Your c is 20. I promise the answer will be a nice answer, but we got to get there first. So your c is 20. One side is 12. The other side is x plus 5. So let's set up the Pythagorean theorem. We're going to say 12 squared plus, I'm going to put the x plus 5 in parentheses and square it, equals 20 squared. Now, if you've had algebra 2, you're like, oh, great, a quadratic. I'm going to treat this x plus 5 right here as one gigantic x. I'm not going to square it, or even algebra 1, I think you've had to do some double distribution here. I'm not going to do that. I'm going to leave this as one big x. 12 squared is 144 plus x plus 5 squared. Leave it like it is. 20 squared is 400. So again, I'm leaving this as one big x. So move the 144 over. bring your one big X down. X plus 5 squared equals 256. Now we're going to square root it to get rid of the whole thing. So the square goes away and I'm left with just X plus 5 equals 16. Subtract 5 and you get X equals 11. That's our X. X is 11. It really just had one extra step. That's it. It looked intimidating, but it wasn't. It just had one extra step. You just had to subtract 5. That's it. Okay, so there's the guided practice. If you have questions, you can ask me for help. You know how to reach me. In the meantime, remember, you are awesome and you were created to do great things. Always believe.